Welcome to Unit 10, Part 2. We're going to talk about how to measure angles and arcs in a circle. So there's a couple key vocabularies. First of all, a central angle is an angle whose vertex is the center of the circle and whose sides are radii of the circle. So look here, angle 1, 2, and 3 are all central angles. An arc is part of a circle. So if you look here, the arc formed by angle 1 is right there. So that's an arc. Adjacent arcs are arcs that are next to each other and have only one point in common. So for example, these two arcs here are adjacent because they're right next to each other. Arc measure is the measure of the arc, and it's equal to the measure of the central angle. So if this angle is 120, then this arc is also 120. Arc length is the measure of the length of the arc. So that would be like the distance. So it's like the circumference part of the arc. And congruent arcs are arcs that have the same length. So if you add up the central angles, notice in a circle, there's 360 degrees. So all central angles have to add up to 360 degrees. A minor arc is the shortest arc connecting two endpoints on a circle. So a minor arc is always less than 180 degrees. Whereas a major arc, that is the longest arc connecting two endpoints on a circle, and that is always greater than 180 degrees. And it is always 360 minus the minor arc. And a semicircle, that's an arc that is half the circle, or 180 degrees. So a minor arc you only name with 2 letters, whereas a major arc you name with 3 letters, and same with a semicircle. So if WC is a radius of circle C, identify the arc as major, minor, or a semicircle. Find its measures. So arc XZY, that would be a semicircle, because that's half of the circle. WZX, that's a major arc. And arc XW, that's a minor arc. All right, so next, in the same circle, or in congruent circles, 2 minor arcs are congruent if and only if their central angles are congruent. So if angle 1 and angle 2 are congruent, then these 2 arcs are congruent as well. So it says bicycles bought by type, and it gives you percentages. And it says find the measure of arc KL. Well, KL is right here, and that is 37% of, oh sorry, KL is not there. That's KJ. KL is right here, that's 21%. So if you go 360 times 0.21, you get that it's 75.6 degrees. And JL is this arc all the way around, so it's 26 plus 37, which, sorry, it's NJKL, so it'd basically be 26 plus 37 plus 21, so it'd be 84%, so it'd be 360 times 0.84, which is 302.4 degrees. Because basically the only part that it wouldn't be is the 16% right there. All right, so the arc addition postulate says the measure of an arc is formed by 2 adjacent arcs is the sum of the measure of the 2 arcs. So if you want to find angle or arc HIJ, which is right here, HIJ, you know it's going to be 32 plus 90 because the two central angles are 32 and 90. So 32 plus 90 is 122 degrees. IJK, so this is 90, and if this is 32, well, 180 minus 90 plus 32, so 180 minus 122 would give you 58. So that means this is 58 degrees, which means the arc is 58 degrees, which means IJK is 90 plus 58, which is 148. So that's how the arc addition postulate can help you. So arc length is the part of the circumference that the arc takes up. So to find arc length, you basically have to divide the angle by 360 and multiply it by the circumference. So if you look here, it says find the length of DA, arc DA from here to here. Well, that arc is 180 minus 28, which is 152. So to find the length of DA, you take 152 over 360 times 2 pi times 6. So 152 over 360 times 2 pi times 6, when you put that in your calculator, gives you 15.917 centimeters. So that is the length of the arc. So here, in the next one, the length of DA is the arc, the measure of the arc is 40 degrees. So 40 over 360 times 2 pi times 4.5. So when you multiply, you get 3.142 centimeters. So for DA here, the arc is 140 degrees. So 140 degrees divided by 360 times 2 pi times 6, and that gives you 14.661 centimeters. So next it asks you to find JL, the arc length. So the angle is 135, so 135 divided by 360 times 2 pi times 14, and that gives you 32.987 centimeters. So for this one, it's 36 degrees over 360 times 2 pi times 6, and that gives you 3.770 centimeters. The last one for JL, it's 158 degrees. So 158 degrees divided by 360 times 2 pi times 14. And that gives you 38.067 centimeters. All right, number 17. So in circle O, BD is the diameter, and the measure of angle AOD is 55. So it says find the measure of angle COB. COB is here. So AOB, if AOD is 55, so 180 minus 55 gives you 125. And then you know that these two added up is a semicircle, so 4x plus 18 plus 10x minus 6 is equal to 180. So 14x plus 12 is equal to 180. Subtract 12. 14x equals 168. And x equals 12. So to find the measure of angle COB, you go 10 times 12 minus 6, which is 114 degrees. So that's COB. Then for DOC, you have 4 times 12 plus 18. So 48 plus 18, which is 66. And then for AOB, we already found that to be 125. So it says here, number 18, to refer to circle P. So the measure of arc LM, that's equal to the central angle, so that's 150 degrees. MOL is all the way around, so that's 360 minus 150, which gives you 210 degrees. All right, so next Diane runs around a circular track that has a radius of 55 feet. After running 3/4 of the distance around the track, how far has she run? Well, 3/4 of 360. 4 goes into 360, 90, so that's 270 degrees, right? So basically 3/4 times 2 pi times 55. Well, when you multiply that out, you get 259.181 feet. So that's how far she's run. All right, that concludes part 2 of Unit 10.